Good evening, guys. All of you are here. You're welcome. I'm glad you managed to have some time to join this workshop. In this workshop, my name is Fred Mutesa, and I'm a FreeSWITCH trainer. I've been one of the advocates of FreeSWITCH, the open source community. I have videos on YouTube. If you go to YouTube and find and search for FreeSWITCH with Fred, you see most of the videos I've done to cover FreeSWITCH. In this workshop, I'll be demonstrating how to register extensions and I'll beg you to kind of like mute your microphone when you join the conference. Thank you. So I'll be demonstrating how to register extensions, and then we shall go into basic call routing in FreeSWITCH. If you are new to FreeSWITCH, FreeSWITCH is an open source soft telecom switch that will enable you to configure voice over IP or voice over network, and you can do a lot of things. You can set up call centers, you can set up PBX, you can set up call termination using FreeSWITCH. In this workshop, it will be really basic, but I'll try to go into details of call routing to help you see how this is done at the very basic. First of all, if you have installed your FreeSWITCH instance, you will need to know the directory structure of your installation. That is, where are the files kept? Where do you need to go if you want to do a particular task? So on this slide, I'm showing you a few commands that we use to get help, and I will demonstrate that right here. The way we connect to the FreeSWITCH console, if it has been installed, we type fs_CLI, and that will bring us to the FreeSWITCH console. That is where we type the commands that we use to control our FreeSWITCH instance. The command we use to see the global variables is global_getVar. So this command will basically give us all the global variables that are currently running. But since we are interested in knowing the structure, the directory structure, I can do that using the Linux console by typing fs_CLI -x. That command basically executes a command inside. I'll do global_getVar. And then on that list, I want to list all the directories. So when I run that command, I get all the directories where my files are. For example, this shows us that our recordings will be found under var_lib FreeSWITCH, and sounds will be found under user share. Config directory is etc FreeSWITCH. Logs will be found in var log FreeSWITCH, and the run directory and the db directory, the modules, the scripts. So that command is vital if you, for example, have logged into a new FreeSWITCH instance that you did not install. That command will help you to know where to go. So currently, I'm interested in the config directory, which is etc FreeSWITCH. Of course, I knew my configurations were inside etc FreeSWITCH since I installed this instance, but just in case you are new to this and you want to know where these files are. So if I've gone into inside etc FreeSWITCH, that is our structure. The file you're most interested in the very beginning is vars.xml. This file will basically have commands we'll have variables that we use in the FreeSWITCH installation or in the FreeSWITCH operation. The first variable you're interested in or you want to modify first will be the default password. If you've installed your FreeSWITCH and you're using it for the first time, the default password for the default extensions or the pre-installed extension numbers will be 1234. And as a reminder, FreeSWITCH shipped to coded inside FreeSWITCH the configurations to make sure that they remind you to change this password. They put a code that delays the calls for 10 seconds. So if you've installed FreeSWITCH for the first time and you do not change the password, it stays on default. Every call you make from the local extension will delay for at least 10 seconds before the call goes out. That is something that was done, and when you look at the console, you will see those errors telling you please change the default password. So right here, I just added a 5 to make sure at least the default password is different. And another comment I'll make here, this line here has the X pre-process variable. These are read by FreeSWITCH. When FreeSWITCH is starting, these are some of the variables that are read. And it cannot be commented out with the normal XML comment tags. For example, I cannot type the less than sign and exclamation mark and dashes. It will not work. So basically what you do, you have to at least modify this word X pre-process, and then maybe you make it Z instead. That is the only thing, that's the only way you can comment that line out so that FreeSWITCH does not read it when it's loading. If you comment it using the normal XML tags, it will still be read, and you might find challenges when you're trying to update passwords, but your original configuration was still there. Sorry, I want to show you other variables that are found in this file. You find the domain. You can configure the codecs. The global codecs. You can configure the IPs for the C profiles here. This variable is very important. If your virtual machine or your FreeSWITCH is behind that, you can tell FreeSWITCH that my external IP or my public IP is this, and then it will do the NATing for you. Then you can also do the RTP IP and SIP IP. I mean, there is so much you can do in this file, and all you have to do is go in there and try to look around. Okay, I'll jump out of that and head back to the presentation. Okay, of course, in this slide, I'm still emphasizing the fact that the default password for the SIP extensions or Sophia extensions is in vars, so we modify that. Inside there, of course, I just added a 5 to make sure that the password is different. And if you want to check that password without going into that file, probably someone changed it, you just have to go to the console. Go to the console and type evaluate which is eval default password. And that will display the default password on your FreeSWITCH, that the password that your extensions are using. So after doing that, you also need to know that FreeSWITCH comes with default extensions, and these are found under directory. So you go into etc FreeSWITCH directory to see under default. I go inside the default folder. You see the XML files. Each XML in this case represents one extension. So FreeSWITCH ships with 20 extensions. That is from 1000 to 1019. If I show you the structure of, let me say 1000, that will tell us, let me try to increase this a bit so that we can all see it. Okay, so you can see why this extension will use the default password, because we have mentioned this variable here and telling it that your password is default password. Of course, these $2 signs will tell FreeSWITCH that this has been defined somewhere under XPreprocess variable. So for voicemail, it is using 1000, and then user context is default. I will explain what that is later. The effective caller ID of this user is 1000. The effective caller ID number is 1000. And then it is saying that we are telling it that when you're making outbound calls, use outbound caller name. And then the outbound caller ID number, use outbound caller ID. So what do these values represent? You can still go back and use the method I just showed you to see what outbound caller ID we have here in this case. Okay, I can say FLS, sorry, I can say evaluate outbound caller ID. So you can see it is telling us FreeSWITCH will send only zeros as outbound caller ID. So if you want to change that, you can still go back into VARs and modify that variable, or that global variable, outbound caller ID. So that's it. The next step, I want to register an extension. I want to register an extension. I will come here and use a soft phone. I have two Zoipa versions of soft phones registered here, but I'll show you anyway. So I have 1000. I can create another one, 1003. It's a SIP extension. And then you put the IP. So the user is 1003 at 41.190.153.91. That's the IP. And the password, we set it to 12345. And the domain, of course, is 41.190.153.91. So it will test the configurations, and you can see it tells us your account has been added to the list. So on closing that, you can see here that the extension is registered. I can go and test this to see the configured extensions using the command show registrations. So you can actually see I have 3 extensions registered. I have 1000, I have 1002, and 1003. They're all registered from the same IP, as you can see here under the contact. They're all registered from my laptop here using soft phones. Now, we have successfully registered extensions, and I've managed to show you the default configuration and where those extensions are found. Okay, let's get the concepts. Of course, in this graphic, I'm showing you that the extensions 1000 and 1001 are registered internally inside the FreeSWITCH profile. But we need to understand some concepts about FreeSWITCH. When you look at this graphic here, FreeSWITCH by default has 2 profiles. Like, it's kind of split. The internal phones will register on port 5060, and this will be, they'll be using the default context, and they'll be using the local extension in the dial plan, and they will be using the internal SIP profile. So this SIP profile is for the internal phones, or the phones inside your network. If you want to connect FreeSWITCH to the outside world, maybe if you want extensions to register from the external network or the public context, you're going to use port 5080. So that is very important to understand that FreeSWITCH has 2 ports. 5060 is for your phones inside your network, and then 5080 is for the phones outside. We can still register SIP phones from outside, but the routing will be different because those phones registered from outside will be hitting on port 5080, and they'll be using the public dial plan, as I'll show you. So in that graphic, I'm showing you that 5080 is the external side, and then 5060 is the internal side. Let's get a few details here. SIP profile will bind specified address port combo to FreeSWITCH. Each profile needs its own port. That's number 1. That's why we have 2 ports, because we have 2 profiles, the internal and the external. FreeSWITCH will listen for signaling on that port and respond according to the profile parameters. Of course, the vanilla configs have these ports, and these ports can be modified. It's important to remember that these ports can be changed. We can go inside those SIP profile configurations and we change those ports. For users that register to your FreeSWITCH and make local calls within, we use 5060. For registering to gateways, outbound trunking, receiving outside calls established through this vanilla profile, we'll use the public context. So once you have those 2 concepts, it will be easier for you to configure FreeSWITCH. Let's try to take a look at the internal profile. The internal SIP profile, it is found under SIP profiles internal.xml. Let me explain here and then we shall take a look. When you go to that file, these are some of the XML commands or XML tags you will find. The first is the SIP port. You will find that variable internal SIP port, and you remember from the very beginning I showed you how to check. I can even go to the console and evaluate internal SIP port, and it tells me my internal SIP port is 5060, but it can be modified. So once you remember how we change the password, it will be easier for you to modify these ports. And then the context we are using is default. So dial plan context used for calls that come in via this profile or via this IP on that particular port. And then the dial plan, we are using XML dial plan. So it's basically telling FreeSWITCH that we're using mod XML call for the dialplan, and then we are defining that SIP trace is not on, but you can turn it on using Sophia profile internal SIP trace on. So you can decide if you want this profile to have SIP trace turned on by default. You set that value. Do you want to log authentication failures? Which codecs do you want to use for this particular SIP profile? So these are things you define, and of course you see we are referencing the global codec preferences that were set inside var.xml. Then we also define the RTP IP, the SIP IP, and in this case we are saying use the local IPv4 IP of your server. Now, in addition to the RTP IP and SIP IP, we are also defining the external RTP IP and the external SIP IP. Those are IPs that are global, so they're accessible from the outside world. Once you define these variables, FreeSWITCH will be able to handle nothing for you. So you won't have issues of one-way audio, no audio. Once you have those configurations set properly, then calls will be having proper audio. Let's go into that file and see what is there actually. So we go under, I'll take a step back. We are going under SIP profiles, and it's in internal .xml. Sorry, it's not CD. I need an editor. VI SIP profiles internal. So you can go through those and look at the variables. Most of the blue lines you see, those are commented out commands in the documentation. So you can go in and try a few things. You can try setting debug, SIP capture. So you can actually see there is so much you can do inside there. All right. Because this is a simple workshop to show Callrouting, I won't go through the whole code of internal XML, but at least you have the concept. There are also values that you might need to know also found inside this file. Of course, I'll give tips on them. You might have so many extensions, and since you have NAT, you might want FreeSWITCH to keep checking if these registrations are live. The first option is all reg options ping. Send options packets to endpoint to keep them live. You need to keep pinging the endpoint to make sure that it is still registered or it's still there. So that if it's offline, you're able to remove, FreeSWITCH is able to remove resources and tag it as unregistered. Then there is unregister on options fail, unregister the phone upon failure. If no reply, then we unregister the phone. Ping NATed endpoints periodically to keep alive. Those are options. You can try and test and see. Of course, they're variables. If you have so many extensions, you don't want FreeSWITCH to be sending so many ping packets on the network. So you might create an interval. You can tell FreeSWITCH you can send the expiry option every 60 seconds. And then you can also do the frequency and the mean average interval so that it can ping a batch after 30 seconds, it pings another batch and then goes around. These are all options we use to play around when we are dealing with registration. Of course, this is how you would change the SIP port. You can make it 5064, and then when you do SIP profile restart or SIP profile SIP Sophia status, Sophia status, and actually see FreeSWITCH gives you the profile details, and it tells you I have the internal profile here. and Mod Sophia is running on this IP at port 5060. Yeah, the other concept you need to remember that there is a possibility of each endpoint registering to FreeSWITCH, and then after the call is live, we want to have RTP audio flowing in between the endpoints. Then we also have routing, outbound routing. We can route calls outside the signal wire network and call out. If you missed my workshop yesterday for connecting FreeSWITCH to signal wire, you can feel free to watch it again. It is on YouTube under the FreeSWITCH workshops. So, but again here I will show you how we do outbound routing. But before we go into outbound routing, we want to first of all see how does FreeSWITCH handle the local calls. How does it know that if someone calls 1000, I need to check the local network? How does it know? We need to look at the dial plan. How does the dial plan know where to send calls for local extensions? Sorry, I will go back here. So with the concepts I've given you, if you want to deal with the dial plan for the internal profile, we said the internal profile uses the default context. The context is where FreeSWITCH will look when an internal extension makes a call. If a phone is inside your network, if it tries to contact FreeSWITCH, maybe make a call outbound, FreeSWITCH will check the default profile, sorry, the default context. Let's go in there and see. If you're looking at dial plan, of course, it will be under dial plan. When you look at the dial plan, we have the default dial plan and we have the public dial plan. In this case, since I want to know the extension 1000, when 1000 calls 1002, if I want to know what will happen, I have to go under default.xml. And there are different dial plans and different functionalities that have been configured in this file. I will not go through all the details, all what happens inside here, but there are different extensions. If you see, we have an opening tag and a closing tag. Those are instructions for one particular service. But in this case, I'm interested in showing you how we handle the local calls. And those are handled under the extension called local extension. It's called local underscore extension. Let's take a look at what exactly happens inside there. First of all, when a call comes in, and the first thing FreeSWITCH will do is to check the condition. Which number is this extension calling? Remember, the user is registered. Now, when you make a call, the first thing FreeSWITCH will do is to check what digits are you dialing. In this case, we have a regex here that says if someone is dialing 10, those are the first two digits, and the third digit is 0 or 1, and the fourth digit is a number from 0 to 9, do the following. The action is export and set dialed extension to $1. $1 means the result that we got here. So in this case, if I call 1000, $1 will be 1000. So FreeSWITCH will basically set it will export the dialed extension variable as 1000. And then it will go further and set actions on the different legs. For example, here we do bind meta application. Bind meta app basically kind of binds some functionalities on a call leg, so that that person or the caller is able to press, or the callee is able to press digits and trigger some kind of functionality. An example I can give you is attended call transfer. If someone receives a call, they can decide to press 1 to transfer the call to someone else. In order for that person to achieve such functionality, this is the section that allows that. And then we also send a ringback tone, and then we set music on hold, and then we set a call timeout. And after doing all that, we bridge. This is basically the line that calls the other extension. If you call the dialed extension, we shall call user/dialed extension and then the domain name. Of course, FreeSWITCH, when FreeSWITCH dials that, it will notice that this call is going to a local extension and it will ring that particular extension. Having seen this, if this person is not registered, the one we are calling, FreeSWITCH will answer the call and it will wait for 1 second and it will tell you to go to voicemail. So these are configurations that come shipped with FreeSWITCH. So if you go in and register extension and try testing it, you will hear FreeSWITCH telling you this extension is not available. Please record your message after the beep. All those are done by this particular section of the dial plan. Let's make a test call and see how these things really happen. Let me open the console, and then I will I'll make a test call here with my Zoiper extensions. Okay, I have 102 and I have 1000. So let me make a call to 102. 1002. First of all, let's make sure that the call works. If you see in the background, I see some log files showing the FreeSWITCH detected the call. And if I click on Zoiper 5, it shows me I have an incoming call from extension 1003. And if I answer that, of course, I'll have audio. I can hear myself inside the headset, though you can't hear me, but the call connected. Let me hang up and we go back to see what exactly happened. When you go back on the console, let's go back to the very step. There are so many logs, but we can go back to the very first step here. FreeSWITCH tells us there was a new channel and the call is going to internal. Sorry, the call is coming from internal 1003. And it tells us there was an invite from this IP. So it goes on to verify the domains. And then it reaches here and tells you there is a new call going to 1002. And we are using the default context. So this is our call I made, 1003 to 1002. Now it starts going through the regex, the conditions at this step, and it shows a result at every stage. Oops, sorry. To go back here. It showed like it goes through and starts testing that dial plan. Destination number is 1002. It compares it to this pattern. and the result is false. It starts comparing different stages, different patterns, until it reaches a stage where it gets a correct pattern that matches, and then when it gets that pattern, it will terminate the call. Let me see at this stage where it selects I want to bring you here where it finally figures out here, local extension. It finally figures out that this extension 1002 matches, and it will export the dialed extension as 1002, and then continue doing every step that we saw in there. It will do the bind, it will set the ring, and then at that point, of course, since the user is registered, you see it will start executing different commands. That's what you see in green happening. So once you set up your lab and try to do this, you will be able to see. And at this point, sorry, it is starting to send the ring ready, and it will start sending early media. So the other party will be able to hear the phone ringing. And then you can also see what codecs that have been tried. Then you can see somewhere here, there are some codecs that have been saved as a match. It is saving PCMA and PCMU, and then doing a codec negotiation. So basically, that's how we manage to manipulate. That's how we manage to manipulate the call between a local extension. On the FS console, you will see so much happening. There will be so much happening that you'll be able to troubleshoot. Let me try to troubleshoot with you a live call. So the live call here, I'll make another test call and keep it going so that we can look at a few things that are happening. Let me make a call from 1000. 1000. Okay, I'll call 1002. And so once that call, you can see the call is ringing. And once I answer the call, hello? Hello? So I can hear myself. I will go ahead and mute so that it saves my ears. But at least that call is live. Let's go to the console and see what is actually happening. I'll first jump out of the console, and now if I want to see the live calls, I can do show channels to actually show you that there is an existing call going on. Of course, on the console, you might not see everything clearly, but another tip I can give you is that you can copy this content here, right here, and put it on Google Sheets. So if you go to docs.google, you can create a new spreadsheet, and all you have to do is to paste there, and then you click on this icon that pops up after pasting, and you click split text to columns. Once you do that, the spreadsheet will be so kind that it will split the values for you with every column named accordingly. So in this case, you see the UUID, we have two UUIDs. UUID is a unique ID for every leg. So in this case, we have the inbound leg and the outbound leg, depending on who called who. And then we have the name. These are extensions involved. We have 1000 and 1002. Of course, they're all originating from the same IP. Like I said, they are registered on my laptop, and the destination is 1002 because that's the number we are calling. And we can actually see PCMA is the codec that was negotiated. So there is so much you can see here. And now, what if you have a problem and there is no audio on this call? What if you have no audio on this call? There are things we can do to check or to test the functionality, or if one end user is muted or they have an issue, you can broadcast audio from the command line to the different parties, either to A leg or B leg. And what we do there, I'll first rush you through the presentation so that I don't want to jump things. So this is what I was trying to explain about the call legs, that when one party calls, one phone calls the other phone, the phone that is calling will be the A leg, like you're seeing in this graphic. For example, this is a graphic where the boss is calling you. So the boss in this case will be the A leg, because the boss's call will first go to FreeSWITCH, and then FreeSWITCH will route the call to you. And so which means from FreeSWITCH to you, that is the B leg. So in this case, the A leg is the inbound and the B leg would be outbound. So I was mentioning that there are some variables or UUID commands you can use to check the legs. You can answer a leg, you can broadcast, you can check audio, you can debug media. So you can check to see if actually RTP packets are flowing in a particular leg. Let's test debug media in our particular call. You can see the call still is there, but I can do UUID, and to see all the commands, you type UUID and then you tab. Every time you press tab, you will see different all the different commands that you're supposed to use. So I want to do debug media, and once I tab again, it will show me the legs, the UUIDs for both legs in this call. I want to debug for this leg. Because when I press enter, it shows me the syntax is wrong, but I wanted to show you the format of this. So I can say both on. I can say both on. UUID debug media ID both on. Options. Let me see if I'm using the correct ID. Read on. So the syntax is read on, and you see that actually the packets are flowing. I'll turn it off and show you again. Off. show channels, and in this case, I'm just showing you UUID media, the read option, and then setting on. You will be able to see, let me see the right option. The RTP packets are flowing, so you can actually see that we have RTP packets flowing between the two IPs. That is FreeSWITCH and my IP on those ports. I'll turn it off. So my FreeSWITCH is running on this IP, and it is negotiating, or it's able to transmit RTP packets between FreeSWITCH and the call. So that is a one way you can troubleshoot audio. You can even use the broadcast. You can use the broadcast, UUID broadcast, and that would be UUID broadcast. You put the UUID for that leg, and then the path to the file you want to play to that person, and then you define the A leg or the B leg. So if you send a call to, you want to play a message on that leg, this is how you do it. So this first command here, the file plays on inbound leg. B, file plays on outbound leg. And of course, when you use both, the file will play to both endpoints. So we can have a call going on, and then me as an admin, I can use UUID broadcast to play a message to all the participants in that call. Okay, I will go and take you back to the dialplan. How do we make outbound calls via the gateway? So, like I said, I already demonstrated how you can connect FreeSWITCH to SignalWire, but we still want to know, what if I want to call outside? What if I want my number? Let me first end this call. I had forgotten. Let me first end this call. What if I want to make a call to an international number, or make a call through my gateway provider? Still, since you're calling from the internal network, we are going to check the default dial plan, and inside the default dial plan, we define different patterns. The pattern under local extension was a pattern for only local extensions. Now we put a pattern that will accommodate an E163 number. In this case, we are still under dial plan. You can do it under default.xml, like I did here. So this simple dial plan basically means that if someone is calling out and their destination number starts with a plus sign, the question mark here means it's optional. So the number could have a plus sign or not. And then the next D plus means any digits. So if I call a +1 and stop there, still this dial plan will match. If I call +1000, still this dial plan will match. And then, of course, the call we shall answer, and then we send the call. Of course, this answer is not really necessary in this case, but just to demonstrate how a dial plan is constructed. And then we bridge the call to the gateway signal wire, and then I told you that $1 means the result of the regex in the brackets. If I add more brackets here, the variables will be $1, $2, $3, depending on the number of brackets that you have. Okay, so with this dial plan modified, I will save and go back to FSCLI and reload. You can do reload XML to reload the dial plan, or you can do you can reload module. You can reload the module itself. Reload mod dial plan X XML. So those two commands can help you. Sometimes I use both of them if I make so many changes, but one of either should work. So in this case, I want to make a call to my number here from any of these extensions. So if I type plus 256-754-8086, that should make a call and ring on my phone. It's ringing. I want to see it pop here. You can see the call is coming in. So if I hang up, of course it will stop. But let's see what happened. If I go back up, we see we had a new channel was created. Sorry. I'll go back to the very beginning so that things make more sense. We have a new channel. The user 1000 is actually making a call, and once it pops in, we want to try and see which number they are calling. They are calling plus 256-754-8086. And of course, we answered the call. Sorry, before that, we matched our pattern here, which sent the call to the gateway signal wire, which is connected using the mod signal wire. And of course, the call was answered. Packets started flowing, and then we negotiated the codec. And then here, the call is bridged on my side. Of course, I didn't answer the call on my side. I just killed the call. So when you look at the logs, FreeSWITCH tries to show you whatever is happening. You can even see RTP ports being negotiated. And then it tells you no more clearing, the caller hung up. And then we have the state hung up here. So in a nutshell, that is how you make the routing for outbound. And someone might be asking, how do you make the inbound routing? How about inbound? In the few minutes that are remaining, if we are talking about inbound from your gateway, it means this call is going to basically come through the public dial plan. That's very important to remember. It will come through the public dial plan because it's coming outside FreeSWITCH. And if you want to configure that, you go under public, either public.xml or the public folder, and create your XML file there. So if I go under public, and for example, try to put a dial plan here that says call transfer anyone that calls this pattern, transfer that call under the default context. In this case, we are not bridging, but we are transferring a call from one context to another. So this dial plan will basically transfer the call, and I told you $1 is the result of this pattern. It will go into the XML dial plan and transfer the call to the default dial plan. And that way, FreeSWITCH will be able to identify the caller or the callee, and that person will receive calls. If you look at this line here, it includes public folder and every XML file inside there. That means if you instead of configuring your dial plan in this file, you can go inside public and configure, put your XML there to be more organized and make sure everything is not in a bulk place. You can create a different file for every route. In this case, I have this file, this code here, which means that if someone is calling from outside and they're calling 555-1212, you're going to get that domain name and transfer the call to 1000. So if someone from outside is making a call to that number, the call will be sent to extension 1000. So I hope That makes sense. So in summary, that's all I had today for call routing. And before, registering extensions and doing basic call routing. If you want to do more advanced training in FreeSWITCH, we offer virtual training. There are two options. You can go to freeswitchsignalwire.com or freeswitch.com to see the options for FreeSWITCH training. There are 4 hours training and 8-hour training. You will see the prices there, and it happens once every month on a Tuesday. So you can set a date, and then we give you proper training from depending on what you're interested in. In this video, I did not cover WebRTC. There's so many things I did not cover. But if you're interested in learning more, you can subscribe for that. And I'll say that's it. And I'll open up the platform for the remaining few minutes for any questions that might arise. You might ask the question by audio, or you can post it in the chat if you are using SignalWire Work. So I will, having said that, since I have not received any question, I will thank you for joining in, and you can stick around and be in the lounge, go to different rooms, and probably wait to interact with other colleagues of mine. But for now, I will end this workshop. And again, thank you very much.